Imagine having a digital sidekick that, doesn't just follow simple commands, but can actually understand context, think through problems, and take action on its own. We're talking about moving beyond basic automation
Really stepping up.
and into the realm of something truly intelligent, something that feels, well, purposeful.
Absolutely. And today we're diving deep into the world of building AI agents, not just using them, but actually designing them from the ground up.
And we've got this fantastic source material here. It's structured almost like a course, isn't it? It takes you step by step, level by level,
It does, yeah.
through creating these sophisticated software entities. Think of it like going from what is this thing to being a genuine architect of digital intelligence.
That's a great way to put it. And our mission today is to guide you through that exact journey. We'll explore the key concepts starting right at level 1, the foundations.
A blueprint.
Exactly, the blueprint, all the way up to the complexities of level 3, where these agents start getting really autonomous. We'll see how basic instructions evolve into systems that can pursue goals, learn, even work together.
So think of this conversation as your shortcut, your deep dive into what's actually going on under the hood when you design these agents. We're going to unpack the steps, the layers, just like that guy does. It feels like we're walking through this together, right? Building up knowledge.
Sounds good. Let's do it.
Okay, so let's unpack this. Level 1, where do we start?
Well, at its most basic, an AI agent is, fundamentally, a piece of software designed for a specific objective. And the core of how it works, this loop it's always running, is perceive, process, act, PPA.
Right, PPA, perceive, process, act. And we actually see this basic loop everywhere, even in pretty simple tech we use daily.
We do. It perceives info from its environment, processes that using its logic or intelligence, and then acts based on that processing to edge closer to its goal.
It's a constant cycle.
Exactly. Think about your everyday interactions.
Okay, like a self-checkout machine. That seems pretty simple. It perceives the barcode you scan, processes it, finds the price in its database, and then acts by adding it to your total. That's the loop right there.
Perfect example. Or a smart thermostat. It perceives the room temperature,
Okay,
processes that against your setting, the temperature you want,
right.
and then acts by turning the heat or AC on or off. Simple, but it's the same fundamental loop.
And a GPS navigator. It
Correct.
perceives your location, your destination, processes the route, maybe factoring in traffic,
Real-time data, yeah.
and then acts by giving you directions. Turn left here, These are all early versions of that PPA loop.
Exactly. And the source material we're looking at focuses mainly on goal-based agents.
Yeah.
These guys have a clear mission, and they actively try to achieve it. And this is where your role shifts. You're not just using it. You're becoming the builder, the architect.
Okay, so being the architect, that means you're setting the stage, defining its world and its purpose. The guide lays out these basic steps, almost like you're teaching the agent.
That's a good analogy. Step 1, define the purpose. And this is absolutely crucial. You have to be specific.
Not just vague goals.
No, definitely not. The guide contrasts agent to help with my novel way too broad with something like an agent that's a historical expert on 18th century London, focused on daily life, clothing, social norms, slang. See the difference?
Yeah, much clearer. Specificity gives it focus. It knows what it's supposed to be doing.
Right. It defines the scope.
Yeah.
Then, step 2, connect to a language model, LLM. You're not building the core brain from scratch here.
You're leveraging existing tech.
Exactly. You're tapping into these powerful, pre-trained language models. It's like learning to drive a really fancy car, not building the engine yourself. Your agent framework plugs into this LLM for language understanding and generation.
Okay, so the LLM gives it the language smarts. Then what?
Step 3, provide knowledge. This is where you build this library your 18th century London expert needs. Well, 18th century London knowledge.
Makes sense. You're the librarian.
Precisely. You might upload relevant documents, PDFs, text files, historical records, or maybe connect it to reliable websites. You could even structure key facts in a database. For that London agent, you'd feed it articles, diary excerpts, old maps, maybe a glossary of slang.
You're curating its expertise. Okay.
Yeah.
And then step 4, this sounds like the creative part, crafting personality and instructions.
It really is. This is where you use plain language prompts, directives, to shape its behavior, how it talks, what rules it follows.
So you define its persona, like should it sound like a world-renowned professor?
Yep. And you set rules of engagement. Things like only use the info I gave you, or maybe if you don't know, say you don't know. That's important.
Prevents it from just making stuff up. Hallucinating.
Exactly.
Yeah.
And you reinforce its goal. Your main job is helping the user write an accurate novel set in 18th century London. You're putting guardrails on the LLM and the knowledge.
The source has this hypothetical level 1 exercise, right? Designing an event planner agent for a wedding.
Yeah, that ties it all together nicely. Define its purpose, answer guest questions, provide the knowledge, schedule, directions, hotel info, registry links.
The FAQs.
Right. And then craft instructions. Give it a friendly persona, tell it what it can share, and maybe crucially, what it shouldn't talk about.
Like sensitive family stuff or how much things cost. Definitely need those boundaries.
For sure.
Okay, so those 4 steps, purpose, LLM, knowledge, instructions, that's the basic level 1 blueprint. But just having a static library and simple rules, that's not enough for dynamic tasks, is it?
Not at all. And that's precisely the jump to level 2. This is where it gets really interesting. We move from builder to, the source calls it the alchemist.
Woo, fancy.
Yeah. It's about refining things, adding more smarts, letting the agent interact with the real changing world.
So the first big thing in level 2 is dealing with knowledge differently, advanced knowledge architecture.
Exactly, because that level 1 library, that's mostly static knowledge. A PDF, a recipe, it doesn't change unless you manually update it.
But the world does change. Stock prices, weather.
Precisely. That's dynamic knowledge. And for an agent to be truly useful in many scenarios, it needs access to live, dynamic data.
How does it get that? That's the API thing, right? Application Programming Interface?
That's the key.
Yeah.
The source uses a great analogy. Think of an API like a waiter. Your agent, the diner, doesn't barge into the kitchen, the external service or database.
Right.
It gives a specific order to the waiter, the API, asking for just what it needs. What's the current weather in Paris? The API fetches only that info and brings it back.
So APIs are like the agent's senses, reaching out beyond its own files. It could check flight prices, hotel availability, translate something.
Exactly. It connects the agent to the live external world.
Level 2 also talks about knowledge graphs. This sounds different from just text files.
It is. It's a more structured way to represent information, focusing on the relationships between things.
How does that work?
Okay. Instead of just text like the Eiffel Tower is in Paris, and Paris is the capital of France, a knowledge graph maps these connections visually, almost. You have nodes for Eiffel Tower, Paris, France, connected by edges, showing relationships like located in or is capital of. So Eiffel Tower, located in Paris, is capital of France.
I see. So if I ask, what country is the Eiffel Tower in?
The agent can follow the connections. It finds Eiffel Tower, follows located into Paris, then follows is capital of to France, and figures out the answer, even if it never saw that specific sentence. It's reasoning based on structure.
That's clever. It understands how things are connected, not just keywords.
Yeah.
The level 2 exercise combines this, right? The smart travel agent.
Yeah. You think about what's static knowledge, maybe a packing list PDF, what's dynamic via APIs, flight prices, hotel booking, currency rates.
Yeah.
And how could a knowledge graph map attractions, restaurants, transport, showing how they relate, which metro line goes near, which museum, things like that.
Okay, so better knowledge access. What else is in level 2? Mastering the prompt.
Yes, this is huge. It's about refining how you talk to the agent, how you instruct it. It's more than just simple commands now.
Like zero-shot versus few-shot prompting. Zero-shot is just telling it what to do. Summarize this.
Right. And it might work, but it might not give you the output format you want. Few-shot prompting is where you give it examples in the prompt.
Show, don't just tell.
Exactly. You might show Article 1, Summary 1, formatted like this. Article 2, Summary 2, same format. Then you give it Article 3 and ask for the summary. It sees the pattern.
And that makes the output more consistent and predictable.
Much more. And then for really complex stuff, there's chain of thought, COD.
Forcing it to think step by step.
Pretty much. Instead of just asking which plan is better, you guide its reasoning. First, analyze Plan A's features and cost. Second, do the same for Plan B. Third, compare pros and cons. Finally, conclude and explain why.
So you see its logic and it's less likely to jump to a wrong conclusion.
Absolutely. It boosts reliability and transparency for complex problems. The source suggests trying this for a repair versus replace laptop decision-making. The agent weigh age, cost, warranty, performance, step by step.
Level 2 also mentions agents using tools or even working with other agents.
Right. It's not always one giant AI brain. You can have an agent use external tools like a calculator for math, a web search for current events, or maybe access your calendar. This lets it do things.
Perform actions.
Perform actions, exactly. And you can have agents delegate tasks. A main agent gets a complex request like plan a party, and it might hand off finding caterers to one specialized agent, designing invites to another. It's like a team.
Okay. And crucially, level 2 talks about making the agent trustworthy, fortifying it.
Yes, very important. Building an evaluation set, basically, a test suite. You run it regularly to see if your changes are actually improving things or accidentally breaking something else.
Quality control.
Exactly. And implementing guardrails, hard rules the agent just cannot break.
Mm-hmm.
Never give financial advice. Stick to 18th century London.
Non-negotiables.
Right. Plus, setting up user feedback loops. Even a simple, was this helpful? Yes, no, gives you vital data on where it's succeeding or failing in the real world.
So level 2 is about adding dynamic knowledge, structured data, smarter prompting, giving it tools and teammates, and building in safety and evaluation. That's a big leap.
It really is. You've got a much more capable, controlled, and robust agent. But it's still mostly following your detailed instructions or reacting to specific triggers.
It's not truly independent yet.
Exactly. And that's the threshold we cross into level 3, becoming the sentient architect.
Okay, sentient architect. This sounds serious. This is autonomy.
This is where we design for autonomy, giving the agent the capacity to think, plan, learn, and act on its own towards higher-level goals, not just waiting for precise instructions.
How does that even work?
The core engine for this, described in the source, is the OD loop. Observe, orient, decide, act. It's a continuous cycle the agent runs proactively.
Oh, DA. Okay, break that down. Let's use an example, maybe that online store agent.
Good one. So, observe. The agent is constantly monitoring things. Inventory levels, new customer reviews, website traffic, sales figures. It's not waiting to be asked.
It's always watching.
Always watching. Orient, it makes sense of the observations. Stock is low on product X. That's a problem. And hey, product Y is getting amazing reviews. That's an opportunity.
Connecting the dots.
Right. Decide. Based on that orientation and its overall goal, maybe maximize revenue, it forms a plan. Okay, I need to reorder product X, and I should promote product Y because people love it.
Makes a plan.
Act. It executes the plan. Sends an email to the supplier for X, drafts and posts a social media blast about Y, maybe alerts a human manager. And then
the loop starts again. It observes the results of its actions.
Exactly. Observe the new state of the world. The big shift in level 3 is you give it a high-level goal. Improve customer satisfaction, not just specific instructions. The agent uses ODA to figure out the how and when. The source has an exercise mapping ODA for a website guardian agent, which is quite illustrative.
Okay, so ODA drives the autonomy. But how does it handle a big goal like organize an online workshop? That needs planning.
It does. And that's where dynamic planning and task decomposition come in. The agent needs to break that big goal down into smaller steps.
It creates its own to-do list.
Essentially, yes. For the workshop goal, it might generate tasks like research topics, define title, set date time, set a meeting link, create registration, promote it, send reminders, get feedback. It figures out the sequence and dependencies itself.
How does it figure that out?
It uses conceptual planning techniques, like forward chaining. If I do this, then I can do that. Or backward chaining. To achieve the final workshop, I first need people registered, which means I need promotion, which means it works backward from the goal. It's building its own project plan.
That's pretty sophisticated. But what about learning? Truly autonomous things need to learn from experience, right?
Absolutely critical. Level 3 introduces memory, not just short-term scratchpad memory for the current task, but long-term memory to store past successes, failures, procedures, lessons learned.
An archive of its experiences.
Right. And crucially, a reflection mechanism. This is how it learns from mistakes. After a task, especially a failed one, it asks itself structured questions.
Like what?
Like, what was my objective? What actually happened? Was it successful? If not, why did it fail? And based on that, how can I create a new procedure or update an old one so I do better next time?
It analyzes its own performance. The source had that booking example.
Yeah, the grocery order failing because an item was out of stock. The agent reflects. Objective, order groceries. Outcome, failed, item X unavailable. Then it creates a new rule. New procedure, if item out of stock, try substitution or notify user. It's basically reprogramming itself based on feedback.
Wow, okay, self-improvement. And the final piece of level 3, collaboration. Social agents.
Yes, The really powerful systems are often multi-agent systems,
Sure.
teams of agents working together.
How's that different from the level 2 delegation?
In level 2, it's often hierarchical. Manager agent tells specialists what to do. In level 3, we see peer agents collaborate and negotiate. Think of a smart home. You might have a comfort agent, an energy agent, a security agent. Their goals might conflict.
Right. Comfort wants blinds open for light, energy wants them closed for insulation, security wants a clear view outside.
Exactly. In a level 3 system, they negotiate. Comfort says, I need light. Energy says, I need insulation. Security says, I need visibility. They might broadcast their states and needs, evaluate proposals, and reach a compromise. Okay, let's set blinds to 50%. Some light, some insulation, partial view.
A consensus based on conflicting goals.
It's a dynamic balancing act. And this kind of interaction can lead to emergent behavior.
Emergent behavior.
Yeah, complex, intelligent patterns that arise from the simple rules and interactions of individual agents but weren't explicitly programmed. Like a flock of birds, each bird follows simple rules, but the flock's movement is incredibly complex and coordinated.
So you design the agents and their interaction rules, and complex intelligence can just emerge.
That's the potential, yeah. It's kind of the ultimate goal for the sentient architect, creating the conditions for intelligence to arise.
Okay, this journey from builder to alchemist to sentient architect, it's quite something. But throughout all this, there are ethical things to keep in mind, aren't there?
Absolutely. The source brings these up. Even back at level 1, bias is huge. If your source data is biased, your agent will be biased. You need diverse representative data.
Makes sense. And privacy.
And critical. Agents handle data, often user data. You need transparency about what it does and robust, secure handling of that information.
And truthfulness, especially with LLMs that can, well, make things up, hallucinate.
Right. Building in rules like if you don't know, say so is vital for trust.
And as they get more autonomous in level 3, the responsibility gets bigger.
Much better. The challenge of alignment becomes paramount, making sure the agent's goals and actions stay aligned not just with its task, but with broader human values. That's the ongoing challenge for the sentient architect.
So we've gone from the level 1 builder laying the foundation
Purpose, LLM, knowledge, instructions.
to the level 2 alchemist, refining it with dynamic data, APIs, knowledge graphs, smarter prompting like COTI, tools, evaluation.
Making it more capable and robust.
All the way to the level 3 sentient architect, designing for autonomy with OD loops, planning, memory, reflection, and even collaboration leading to emergence.
It's about designing systems that can perceive, plan, act, learn, and navigate complexity.
It's a powerful toolkit you gain, understanding these levels.
It really is. And the guide encourages you, the listener, to start small. Maybe sketch out a simple agent design. Stay curious because this field moves incredibly fast. Experiment with the tools out there.
Because, let's face it, the future will involve more autonomous systems woven into everything. And maybe the biggest responsibility for anyone becoming a sentient architect isn't just figuring out how to build agents that can think, but making absolutely sure they're built in a way that they should think, that they stay aligned with what's actually good for us.
That's the core of it. Which leads to the final thought. What does it truly mean for you to build for alignment in this rapidly advancing world of AI agents?